glad we have a nice turnout this morning. It's my pleasure to introduce Toni Sebastian, who's a professor in the Department of Earth, Marine, and Environmental Sciences here at UNC. I know we have a few folks on the call that aren't UNC people, so it's great to see people from Raleigh tuning in as well. I'm going to turn it over to Toni in just a second, but I do also want to acknowledge Hope Thompson, who helped make this speaker possible, because it was at Hope's graduation party that I ran into Toni and said, hey, we've got this speaker series. Wouldn't it be great if you took a little time and told us about your outstanding research around the area of compound flooding? So for whatever reason now, when Toni sees me, she walks away from me so she doesn't get stuck having to do anything else. But I really appreciate her being here and look forward to her presentation. Toni, take it away.
Awesome. Well, thanks everybody. I very much appreciate the invitation. I'm going to, let me get my slides up here actually. Is everybody seeing a slideshow version of? Okay, awesome. Well, I really appreciate the invitation. As I think both Steve and Emily mentioned, I'm relatively new to UNC at this point. I probably can't say that anymore, but I've spent most of my time at UNC in some form of like quarantine pandemic. So I haven't had the opportunity to meet all that many people on campus, although everybody has been extremely welcoming, and I feel like I've probably had more opportunity than most. But I will say that it's a pleasure to be able to take this time to introduce myself and also my lab and talk a little bit about the things that we're interested in and that we're working on. And hopefully that will just kick off sort of a discussion where everyone can ask questions, and we can see where it goes from there. Steve asked me to kind of keep it between 20 and 30 minutes, so I'll do my best, and I promise there are no equations and no models in today. Actually, there's one equation, but really no equations, no models in today's presentation. So it's really just sort of an overview of my lab group and the things that we're doing. So just as a little bit of an introduction to myself, I grew up in San Antonio, Texas, so really deep south or central Texas, in an area called Flash Flood Alley. And it only came to me later in college that I had a lot of flood experiences as a kid. So in 1998 and 2002, there were these two record-setting large flood events that occurred in San Antonio and flooded much of the area that I lived in, as well as sort of the pictures here are this area behind a large dam in San Antonio. So I guess my exposure to flooding came quite early. What I didn't know at the time and later learned was that the city had built a large tunnel system underneath the downtown area in 1997 that really protected much of the financial capital of the city. And so my exposure to flooding came early, and my protection from flood control came early as well. And that probably spurred a lot of my interest to go on and study civil and environmental engineering at Rice University. So a bit of background on my education. I have both bachelor's and PhD degrees in civil and environmental engineering from Rice. I also spent a year in the Netherlands at TU Delft during my PhD and went back as a postdoc after my PhD. So I've spent a couple of years living in the Netherlands. And during that time, Hurricane Harvey happened. And it was a good opportunity and a good excuse to come back to Texas, where I worked for a year as a postdoc at Rice, and then later as an associate research scientist at Texas A&M University, where I was doing a lot for the state of Texas with respect to recovery and resilience. But if I map this in terms of flood events, I lived in Houston for a little over 10 years, and during that time, there were some 7 or 8 odd flood events, and these are only the most major events. So Houston experiences a flood event on average every 2 years, but there are a lot of minor or extreme precipitation events that occur in between that are often not noted in the news that also cause a lot of damage and impact to individuals as well as households. And so it's probably worth noting that, again, I've had some experience with flooding during my educational time in Houston. And this kind of all led me to this topic of flood resilience, which I frame as how can cities better understand, prepare for, and adapt to future flood hazards. And this is something that my research focuses on, and the research in my lab is currently focused on. So thinking about framing the problem, we've seen that despite investments in mitigation over the last 50 to 100 years, the costs of floods are increasing, both in the United States and globally. And flood losses are expected to reach about $1 trillion per year in US dollars by 2050. And what's worth noting about this is that this estimate only accounts for sea level rise and increased exposure in coastal zones. It doesn't account for increased flood hazards due to things like land use, land cover change, development, increasing precipitation in overland areas, and many of the other reasons that floods or that flood damages are increasing. In the US, our primary defense against flooding is accurate hazard delineation. And this was really the topic of my PhD dissertation. In the US, the 100-year floodplain serves as a key instrument for planning. It's what we set all of our development standards around. It's how we determined where and how people build and develop cities and communities. And it kind of serves as a protection mechanism in that way. In the US, on the right-hand side, you can see that FEMA floodplains are mapped for a large portion of the country, but not everywhere. So this is a combination of the FEMA flood maps shown in light blue and the EPA 1% annual chance hazard shown in dark blue, which is an estimate of areas that are unmapped by FEMA, but might be at risk of flooding. And we've seen as a result that a large fraction of losses are occurring outside of mapped areas. So I mentioned that floodplains aren't mapped everywhere, but we're also seeing that floodplains are often, or the mapped floodplains are often 10 to 15 years old, and a large fraction of losses end up occurring outside of floodplains. This map is showing the fraction of claims that occur insurance claims that occur outside of floodplains. And it's worth noting that insurance claims are only a portion of overall losses, or they're only a sort of a representative picture of where losses might be occurring, because not everyone holds flood insurance, and flood insurance penetration is actually quite low outside of flood hazard areas. So we've seen that nationwide, about 28% of damages and 33% of insured losses have occurred outside of the designated high-risk zones since the start of the NFIP program in about 1968. Flood hazards. So one of the reasons that we're seeing a lot of flooding outside of floodplains is that flood hazards arise from a multitude of sources, and floodplains are only designed to capture some of those types of flooding. So for example, floodplains are designed to capture riverine flooding, and they're also designed to capture storm surge related flooding. But we might also see flooding from other sources like infrastructure design failure, or urban flooding, which occurs when rainfall falls so fast that it floods before it reaches the receiving bodies of water or streams. There are also some other types of flooding that are sort of not new per se, but new in the lexicon of flood hazard researchers. So one of these is compound flooding, and compound flooding arises when we have interactions between storm surge and rainfall runoff, for example, or any other types of multi-hazards that might be occurring in the same space or time. We're also seeing increased prevalence of high tide flooding, also known as nuisance flooding or sunny day flooding, which is flooding that's occurring frequently just as a function of rising sea levels. And none of these types of hazards are currently mapped by FEMA or floodplain managers. Coastal communities, coastal communities are really the most at risk with respect to flooding occurring as a function of multiple different hazards. So coastal communities are facing increased flood risk on multiple fronts as a function of these multiple hazards interacting in the coastal zone, but also as a function of increasing development, because these are areas that either for economic reasons or for amenity reasons are desirable to live in, and as a function of global climate change related increases in flood hazards. So whether that's increased precipitation due to severe storms or increasing sea level rise as a function of global warming. And we're seeing that the risks are growing, and particularly in coastal areas. So again, referring back to the FEMA flood claim data that we have, we're seeing that the fraction of insured losses, and actually also the fraction of insurance claims outside of the high risk demarcated areas are growing. So here I'm showing a plot of high risk versus moderate to low risk areas in the Gulf of Mexico coastal counties. And we're seeing that the rate of loss in moderate to low risk areas as designated by FEMA is quickly exceeding the rate of loss that's occurring inside of the high risk areas. And this could be a function of smart development practices, but I would venture to guess it's not, and we can talk about that some more later. On all of this goes to say there's sort of this urgent need to delineate where our current risks are and where our future flood risks are going to be. So I mentioned that our primary tool against flood losses is the floodplains, because they give us information about where the high hazard areas are and they allow us to make smart development decisions. And so we really need to delineate where those are today, because we obviously are seeing a lot of damage outside of them and we're not capturing all the types of hazards, but we also need to delineate where they're going to be tomorrow so that we can make smart planning choices in the current time period. We're seeing that the economic costs of floods are growing. We also know that floods have significant social, environmental, health, and physical impacts beyond just the economic impacts of floods. And then finally, there's a lot of evidence that infrastructure and policy investments now will have significant payoffs in the long term. But the biggest problem with delineating these risks, both now and in the future, is that we don't know a lot about how these flood risks will evolve. So the way that future flood risks will evolve is highly uncertain. So climate change acts as a threat multiplier, and there are also complex interactions between humans, disasters, and the natural or the built environment. We could also think about these as natural, social, and economic systems or engineered systems that are co-evolving over space and time. And so delineating how these flood risks are going to evolve, or how the short and long-term changes in coastal hazards and risks will evolve, is the primary challenge to identifying and prioritizing investments in policy and infrastructure. And so I arrived at UNC in January 2020, just before the pandemic, and started to establish my research group here at UNC. And one of the things we're working on is trying to advance the scientific understanding of these dynamic interactions that are driving flood risk over space and time. My lab group, until recently, had 4 people. Sarah Branham just graduated, although she's doing a little bit of research with us on the side. And my postdoc, Victor, left this summer to start a new postdoc position at Chapman University, but I'm going to present a little bit of their work anyways. Lauren and Hunter are currently students in my lab. We collaborate a lot, both externally and internally at UNC. Some of our external collaborators are, of course, Rice and Texas A&M University on the projects we still have ongoing in Texas. And we've also started some new collaborations with NC State and the Texas Disaster Resilience Institute. We've been lucky to be awarded some funding, both from the North Carolina Policy Collaboratory, which I'm going to talk a little bit more about today, as well as the North Carolina Water Resources Institute. And we have some older funding from the Texas General Land Office and the University of North Carolina at Chapel Hill. So I'm going to highlight shortly 5 projects that are going on in my lab, just 1 or 2 slides per project. So no worries, it'll go quick. But one project is the effects of coupled land use and climate change on flooding in the Houston-Galveston region. This is post-Harvey work. And I'll talk about that first, and then we'll talk a little bit about the projects we have ongoing in North Carolina, specifically around the Neuse River Basin and thinking about long-term changes in flood hazards in the Neuse River Basin. So Houston has always provided an excellent case study. As I mentioned at the very beginning, in the time that I was there was a flood event on average every 2 years. So there were always plenty of floods to look at and always plenty to do. And Houston provides an excellent case study because it has grown so rapidly over the last 100 years. You went from almost no city to this urban sprawling metropolitan area that spans some 70+ miles in every direction. And in addition to just the rapid sprawl, it's sort of at the front of climate change. So they're dealing with sea level rise, they're dealing with extreme precipitation events, and Harvey just sort of served to like underscore all of these challenges coming together in this built environment that is Houston. And I would also note that while it wasn't part of my PhD work or my post-PhD work at the time, Houston also has incredible socioeconomic challenges and disparity. So that's something I've started to get into and think about now that I'm at UNC, but wasn't thinking about at the time. So it serves as this great case study of all of these things coming together and interacting to exacerbate risks over long time scales. As I mentioned, Hurricane Harvey underscored these things. There were several studies that came out during and just after the event that highlighted the extent to which extreme precipitation that was observed during Harvey was caused by climate change. So studies sort of ranged between 15 and I think 27 or 18 and 27% more intense due to climate change. And there were also a number of articles that came out that sort of hit at this problem of development as an underlying driver of flood risk in the Houston area. And so one of the projects that I worked on just after my PhD was trying to understand the cumulative impacts or the disentangle the impacts of both climate and development on the flooding in Houston during Hurricane Harvey. So I like to call this study forensic hydrology, but basically what we did was we went back and built a model for the 1900 environment, and we built a model for the 2017 environment, and we were able to turn on and off climate and land use change and look at how individually they contributed to increasing flows in the Houston-Galveston region and how together they interacted to drive increasing risks in the Houston-Galveston region. And so our study basically showed that across the city at all of the USGS gauges that are there, development alone increased peak charges from 1900 to 2017 by about 1.5 times. Climate change, a 20% increase in rainfall increased flood flows on average by about 20%. But what was really interesting in our study and what the key takeaway was that together they nearly doubled peak flows during Harvey. And so this kind of lent us to give the takeaway that the adaptive capacity of the system due to the development change was reduced. So the ability of the system to adapt to the climate changes or to accommodate the increasing precipitation as a result of climate change was reduced as a function of development. We also saw that, you know, together these things were the sum of these parts were greater together than individually. And so that was really interesting. And it also led us to ask some questions about some of the choices that had been made in Houston to mitigate flooding over the last 100 years. So as we all know, flooding in Houston is no surprise. It's located in a very swampy area at the mouth of a large bay where there have been hurricanes for eternity. So no one's surprised that Houston floods. But Houston has made some really interesting decisions and sometimes questionable decisions about how it manages its flooding. And so one of the studies that we also did after Harvey and had actually started prior to Harvey was looking at green versus gray infrastructure approaches to managing flooding in Houston. And so the pictures that you see here are two neighboring bayous of approximately the same size. One of these bayous has a natural flood control infrastructure as a result of an environmental movement that took place in the 70s. So they largely maintained the system, although they've done some flood control and channel widening, but they did not concrete line the system. On the right-hand system, you have Brays Bayou, which feeds the Texas Medical Center. And in that system, they concrete lined and channelized the system. And when we look at how the flood hazards in these areas have evolved over time as a function of development, we actually see that the concrete line channelized system is less resilient over the long term than the more natural looking system. We saw that the floodplain between 1970 and 2011 grew by about 4
All right, everyone, I guess be patient. Looks like Toni logged off.
So it looks like she's back on her phone. Toni, can you hear us?
I am. I'm trying to think of the best way to do this. Emily or Steve, would one of you guys share my slides and I can just tell you when to switch slides and I think
Yes.
I'll be able to see them.
I will get that right up just a moment.
Sorry, everybody. I don't know what. Luckily, I was almost done. All right, if you'll go to slide 19, and then I'll just follow. All right, so I think the last thing I'll say is just we found that the natural system was more resilient over the long term and had the ability to adapt to changing land use, land cover. So just to talk a little bit about some of the things that are going on in my lab and that my students are working on. We recently started, so Hunter Quintal, who's a master's student in my lab, is working on a project which we recently submitted an abstract with a fun title called Risky Business, How Humans Will Shape Floodplain Landscapes Over the 21st Century. And we're working on a modeling study for the Neuse River Basin, looking at how future climate and land use will interact to drive flood hazards over the entire basin, but also will specifically, or how they will specifically interact to drive flood risk in the Goldsboro area. So we're kind of zooming into one city along the Neuse River, and he received some funding from the North Carolina Water Resources Institute for this work, and we're also working together with the State Climate Office on this study with Kathy Dello. So next slide. My PhD student, Lauren Grimley, is looking at the chance interactions between different compound flooding mechanisms in the New Bern area. As I mentioned at the very beginning, compound flooding is not something we currently account for in our flood hazard mapping in the US. So compound flooding in this case is the interaction between extreme river flows on both the Neuse and the Trent rivers near New Bern, and high surge levels or high tide levels that might be coming up the Pamlico Sound. There's also the risk of extreme precipitation falling over New Bern itself and any flooding that occurs as a function of that. And so she's going to be modeling all of these different drivers, how they interact and how they might be changing with increasing sea level rise or changing river flows coming from upstream areas. And this sort of came out of a project that was funded by the North Carolina Policy Collaboratory, where we looked at modeling compound flooding in the New River estuary together with Rick Ludick's group down at the coast. Next slide. A project that I'm particularly excited about that we're working on in the lab is looking at decadal trends in design flows across the southeastern US and hopefully soon across the entire Gulf Coast. Sarah Branham, who was an undergraduate in my lab and worked on a bachelor's honors thesis, collected data at over 900 gauges across the southeastern US and looked at trends in 30, 50, and 100-year magnitude design discharges. And she found that about 18% of the gauges show a statistically significant trend in increasing magnitude of the 100-year
prime flood using a 30-year moving window. And when you do that, you get a plot kind of like what's shown in the bottom right, where we're calculating the 100-year level for every 30-year period from the big start of the gauge around 1972 through 2020. And this reflects a lot of the literature, but what's exciting about her work and where we're kind of going with is to look at whether or not these trends are driven by hurricane events. So whether or not hurricanes are modulating trends and design flows in the Southeast and Gulf Coast watersheds. And then finally, on the next slide, there's some work by, oh, sorry, this one's gonna have animations, but there's some work by my postdoc that was just published looking at where there are high rates of expected uninsured loss across North Carolina. So as I mentioned before, flood risk is not just a function of how the hazards are changing or how the natural environment is changing, but it's also a function of expected losses due to interactions between vulnerability, hazards, and exposure. So if you click 3 times, we'll just get them all up there. Victor collected data through the North Carolina Policy Collaboratory work that we had. We got access to a lot of state data, and he collected data on exposure, vulnerability, and hazards using the state level data on these different indicators. And he built a model to predict rates of uninsured loss at the census tract scale. So if you click one more time, you'll see the results of his work up here on the top right. The areas that are in the deepest red are areas where we expect to see high rates of uninsured loss, given what we know about historical insured loss penetration and the hazards and exposure that are in these areas, as well as some of the indicators of vulnerability for these different communities. And if you click one more time, I'll mention that some of our ongoing and future work are looking at how these risks could shift in space and time and who holds the risk after extreme events. And this is work we're doing together with Greg Trackless's lab. Hope's working on this, and it's really the brainchild of HB Zeff, where we're trying to understand how these risks are shifting in space and time and who holds them, whether that's the federal government as a function of insurance, but for the uninsured damages, whether they're held by individuals, local government, or businesses like mortgage lenders. And then I'll go to the final slide so we can get past this awkward 2-person thing and just click all the way through and we'll get all the stuff up on the screen. So just some takeaways. Coastal plain watersheds are faced with the combined risks of rapid urbanization and increasing extreme weather. Natural systems and the built environment interact dynamically to exacerbate risks to households and communities. We're seeing that both in Texas, and we're expecting to see it in North Carolina as well. Determining how to best adapt to these changing patterns and risk remains an open research question. And we've shown that the key to prioritizing investments in policy and infrastructure is to understand where these changes are likely to occur and who is and will be impacted. And then just as a final note, we're here, we're on campus, and we're open for business. We are excited about collaborations and things that are going on around campus. So we're more than happy to open our doors for discussion, and my group and myself are very welcoming. So I really appreciate the opportunity to talk, and I'll let you guys, hopefully I kept it within the time, even with the weird internet problem, and I will let you guys ask any questions that you have, and I'm happy to dive deeper on any of the subjects that I brought up.
Toni, thanks so much. That was a fantastic presentation. Really appreciate your flexibility and jumping on the phone to deal with the internet. I've got three kids in online school, so we're very familiar with the online issues for sure. Real quickly, if I could take the prerogative and ask a question. Your work in Houston and in Texas, did you coming here, do you have any kind of lessons learned from a policy perspective of things that are being done in Houston that might make sense here in North Carolina as well?
That's tough. I would say the North Carolina system is very different in the sense that I think a lot of it has been left largely in its natural state, although not everywhere. But I think Houston is really in a situation where they've kind of built themselves into a place where it's going to be hard to engineer their way out of the problems that they are facing. But thinking about lessons learned in resilience over the last 10 or 15 years, I think there is a natural human reaction to the most recent event that you've experienced. So in my sophomore year of college, Hurricane Ike made landfall, and everyone spent 10 years focused on how we're going to mitigate storm surge. And then Hurricane Harvey came, and it had almost no storm surge, and it became, again, very apparent that Houston faces perhaps greater risks due to extreme rainfall. And this is sort of a dynamic that has gone on for all eternity in Houston. So 1900 was a big storm surge event. The 1960s had a bunch of rainfall events. 2001 was a big rainfall event. So you've seen this flip-flopping back and forth. And I think from a policy perspective, it's important to consider all of the hazards that are facing and trying to mitigate those holistically, instead of just trying to mitigate away one hazard and spend all your money investing in infrastructure against one hazard. I think there's much more resilient ways to think about the multi-hazard environment that these coastal areas are facing.
All right, other questions from the group? Phil, go ahead.
Yeah, I had a question, Toni. Do you think you were saying it's difficult to engineer the problem away in Houston? You know, I know they want to spend $27 billion now for the surge, like an Ike dike. I don't know if it's an Ike dike anymore, but if that's what role do you see being somebody in city and regional planning? We're always interested in urban form, and what role do you see that playing? Maybe in North Carolina in the future. You're looking at New Bern, that type of thing. You know, questions of retreat, questions of, you know, we hate density in Chapel Hill. Every time somebody wants to put up a dense development, everybody reacts with sort of this adverse, you know, clustering and density. But I don't know what your sense is after living so long in Houston and now been here for a couple of years and embroiled in a bit of a controversial engineering proposed solution to our little Booker Creek in Eastgate.
Yeah, I think there's an opportunity. So I kind of mentioned like holistic thinking, and I think we often design infrastructure in sort of this isolated, we come from this isolated engineering place where we aren't always thinking about all of the other alternatives that might not fall into like traditional infrastructure design. I think if you look, so lessons learned from maybe the Netherlands and Houston together is that there are multiple layers of a defense that can be thought about or developed in concert. And so you can think about, you know, a protection strategy, but you can also think about other types of flood risk reduction strategies that are more in the context of urban design and development. So thinking about how we build our cities or redesign things that are currently being flooded, not necessarily that we have to retreat from everywhere, but that we can flood proof or make more resilient our urban infrastructure. And I think that that's a place where planners can really participate in what is resilient infrastructure, or what is the resilient built environment? What does that look like? And how do we do it both in a way that protects or saves lives and property, but also allows us to maybe continue to exist or coexist with water in the places that we live now.
I appreciate that. And I just want to mention something about you. You worked very closely with planners in the Netherlands and at Texas A&M. So you had your fill of them probably up to here, but it sounds like you're a holistic boundary spanning engineer. So thanks. Yeah.
I try not to be just a civil engineer, so.
That's the kind of solutions we need in the future. Yeah.
Yeah, and I think there's some really, if anybody ever wanted to talk about them, there's some really great examples and ways of assessing the cost benefits of some of these more resilient built environment approaches. So, coupling flood warning systems with adaptive buildings that have gates and doors that can be closed during a flood event and withstand, extreme flooding and still be functional places of work. So there's some great examples of how to do that out there, but it all requires a lot of funds.
I have a question.
Sure, go ahead.
As the Hurricane Harvey in 2017 Hurricane Harvey, the storm may have a special characteristics, which is it stalled or meandered over the Texas for a extra period of time, causing maybe multi-states water fall on a single state. So maybe the reason may be the jet stream. So because of the climate change and this type of stalled storm, if occurrence becomes a new normal, then do you think that if same thing happened in North Carolina area, like as hurricanes, it came, started landfall, then it does not move. Then what the North Carolina has the capability or to drain the water fast?
Yeah, so Florence is a great example of a stalled hurricane over North Carolina. North Carolina is unique in that it seems to get affected by hurricanes from multiple different directions, and it really matters what direction that path comes over. So if it's going to come, let's say, up through Florida and drop rain over sort of the Raleigh area while it's creating surge at the coast, you have the potential for interacting high river flows and coastal. So it's all like a timing question, which I think is what you're getting at. I think what's interesting in North Carolina is that there's a huge time lag between when water falls upstream. We're talking about like fairly large river systems, but there are some papers out there, especially for the Cape Fear River, that show what are the conditions, what are the hurricane conditions under which you get really extreme compounding events. Thinking a little bit about whether or not stalling patterns might increase in the future, there's some research that suggests that at least for the Gulf Coast, and this is research that's been done by Pedram Hassanzadeh at Rice University, that there are portions of the Gulf Coast that can expect to see increasing stalled hurricanes in the future, but actually in the Houston-Galveston region, because of the blocking patterns and where they're expected to be in the future, you might see faster hurricanes. So you might actually see bigger surge events, but less of the stalling heavy rainfall patterns. But I think that the science on the future of stalled hurricanes is still pretty out there, and there's not a lot of consensus yet. So I've seen sort of a variety of different approaches to that problem, and nobody's really finished answering the question of what the future hurricanes look like. But it's definitely an open question, and the extent to which it impacts compound flooding is also, I think, a very open question and very dependent on forward speed as well as track. And I think that's hard to predict for the future.
Thank you.
Other questions? All right, going once, going twice. Any more questions, or we're gonna end early and give you 20 minutes back in your day.
I'm also
Okay, thanks
happy
for tuning in, everyone. Thank you so much, Toni. This is a fantastic presentation. We're so lucky to have you here at UNC, and I think your effort to collaborate and get to know people on campus has just been outstanding over the last couple of years, and we really look forward to working with you at IE.
For sure. I appreciate the invitation, and I can stick around for a minute or two if anybody, or we can put my email address in the chat, and anyone can reach out with any questions that they have.
Thanks so much, everyone. Have a good day.
Yeah, Toni, I thought your presentation was great today.
Thanks, Phil. I really appreciate it.
You know, and because we're experiencing something here in Chapel Hill right now, where there's major flood impoundments, 6-7 acres size. They want to take out of a lot of heavily forested, I wouldn't call them old growth, but forested riparian areas and beyond the riparian even that surround Booker Creek, because if you walk around Eastgate or, you know, and behind, and Toni brings this whole perspective, this multi-layer, this comprehensive approach. And it's so obvious that the engineering solution is a cut the trees down, excavate, widen a semi-pristine reaches of the Booker Creek. And we really need that thinking here, and we're gonna have to have it. And so I just, and you give such a, it's the best presentation I've seen where we need to think integratively. And so
Thanks, Phil. I really
yeah. Oh yeah, I think you're really onto something here, and don't leave Carolina. They're going to need it.
Well, I will also say, just in response to Steve's question, because that triggered an idea. Steve's question about policy. One of the things that came out of Harvey was this recommendation for watershed scale planning in Texas. I think city and county lines are often drawn where the water is the boundary between things, and that makes for really incomplete plans. And potentially also, one side of the watershed makes one decision regarding development strategy and other things, and the other makes a different, or the upstream downstream problems. And I think that was something also from a policy perspective that really came out of Harvey, is that you have to take sort of a watershed scale perspective of the decisions that are being made in one part of the watershed and how they affect decisions in other parts of the watershed. And coming to Carolina, I think that's something that Carolina has also done very well already. But it's something I think we all have to keep in the back of our minds, is that there are these interactions at watershed scales that have to be accounted for when making decisions about future development or mitigation strategies or all of the above.
That's a great point, Toni. And having worked at the agency a number of years back, there was a time where the state was doing planning for water quality and water quantity and water resources completely separately. So at least now there's been a little bit of integration into both of those, and as you thinking about things on a holistic watershed scale. So we're at least moving in the right direction. But it's a great point.
Yeah, I think the real costs, because what's going on here, decisions that are made at one end of the watershed, whether it's down or below, if they put big development in, the upper end of the watershed has to pay the price money-wise, and the loss of a natural environment in the case here. Vice versa, it could be upstreams causing a lot of downstream costs, so.
Yeah. And I think that upstream downstream interaction plays out in North Carolina. I think the Raleigh area is really concerned about it, but definitely is playing out in Houston, and actually uniquely maybe in Houston. I think the downstream areas tend to be the older, potentially more vulnerable areas of the city. And so I think that's also a very interesting dynamic to be thinking about, is like, who lives downstream and what does that mean for the quality of the built environment, as well as their financial or adaptive capacity to the changes that are coming from upstream areas. So
and your slide on showing the 1.5 increase in flooding because of was there impervious cover and the different yeah. That's really significant. And I don't know how is it cost effective? They're not keeping up with the stormwater control, the flood control, the Harris County Flood Control District and all that.
I think that is just a problem nationally, is that we build a lot of infrastructure, but we don't always have the funds or the capacity to maintain the infrastructure after it's built. And so it deteriorates. I mean, that's what's going on with the increasing rate of urban flooding, is that we just don't have the funds or the capacity to maintain all the stormwater infrastructure that we've built. And so we're seeing increasing damages in areas where we historically haven't had to map the hazards because we assumed that they were mitigated. And so I think that, you know, that is definitely a problem in Houston, but it's also, I think, a problem at a national scale for the US.
Toni, are you okay if this recording goes up?
Yeah,
Not this last few minutes, but the presentation. Okay.
that's not a problem.
Yeah, I'll edit this part out for sure. But yeah, that was a great recovery. I'm impressed.
I was like, oh no, I have to call in. So I hope it wasn't too
No.
long of an awkward pause, but
Well, I thought it was me. I was like, oh my gosh, Steve, is the video not working? I thought maybe it was my internet. And I was like, oh no, hope this is doesn't ruin everything, but
I appreciate that you clicked me through there at the end. Unfortunately, all of my animations happened to be on those last.
it
four
worked.
slides,
It
but-
worked. I thought you did a fantastic job. So and
Well,
we
I
had a
hope to
lot of
meet-
we had a lot of people. We had a lot. It was a good turnout. We had a really good
Yeah,
turnout.
that was absolutely, Emily. Toni, you should feel very good. That was a much better turnout than we normally have. So thank you
Oh,
for
awesome.
taking the time.
Good. Well, unfortunately, I couldn't see who all was there, but maybe people will reach out to me afterwards. But like I said, I hope I get to meet, well, I've met Steve and Phil, but I hope I get to meet the rest of everybody at some point in person. So if there are IE events this semester or next semester, let me know. I'm happy to come over to Europa. So
Sure.
We'll do. Thanks so much.
all right, talk to you guys later.
See ya.
Bye.